This next example in section 1.4 day 2 is, the title here, it says functions that are defined implicitly. Now what this is kind of just a way of saying we've got this expression, there are a couple of functions that are contained in this expression, but the expression or the relation is not a function itself. So we're going to deal with something in the start that wouldn't actually be a function in and of itself. We're going to pull out two different functions from it. And the way that that's most often going to occur is that when we do some algebra on it, you're going to see a plus minus come out of it, a positive and a negative version, that if you put it on a graph would violate the vertical line test. Before I get to this note, let's talk about this example, just how we work through the details to find the two functions that are implicitly defined by this relation. One thing that you can do, or well, something that you want to do for almost every case, is to solve for y. So I guess the way I would start there is to try to get this absolute value of y by itself. I could add that absolute value of y to both sides, making this x equals the absolute value of y plus 1. So it looks kind of weird right now. There's not a whole lot that we're able to do with this. Next thing I could do is, if I want to get this y by itself, let's move that 1 over to the other side. I'm going to subtract it. So minus the 1, but I'm going to leave the x minus 1 over on the right hand side. Just I want to flip it around a little bit, and then that way we have absolute value of y isolated at this point. Now when you have an absolute value, remember that anytime you put in a positive number, it comes out positive. Anytime you put in a negative number, it comes out positive. So absolute value expressions, whatever goes into there are two possibilities. This is where it splits. So we have a split here where it's one of them, just take off the absolute value bars, and it's y equals x minus 1. That is one of the functions contained in this original expression. The other one contained in this original expression is, if you think about this thing as being in parentheses, having a negative version also. So we have y equals negative x minus 1 as well, which will simplify to negative x plus 1. So we have two different versions that are going to be considered the implicitly defined functions, and it is those two right there. We're just pulling them out in any way we can. We have one plus version and one minus version. Now, one thing I wanted you to see, this note up here, it says, note that y equals square root of x squared is the same as some other type of function. The function that this is, now if you think about what does a square root and a square do to each other, those undo each other. So the temptation is to say that square root of x squared is just y equals x. And that would be part of the story, but let's take a look at the graph of this. I've put this in as y equals square root of x squared. I graph it, and it's a v. Now a v graph is, we've done these before, and we know that that's an absolute value graph. So this is telling us that this is the absolute value of x. Now the reason that that works, or that's the case, is because think about if you put a negative number into x squared. If you put in, let's say, negative 2 squared would be positive 4, then you would take the square root of 4 and it'd be positive 2. So whatever is in here comes out positive as well. We need to make sure whatever goes in here comes out positive. This is something that you're going to use, this is a fact that you'll use on number 43 on page 117. So just be watching for that and refer back to this if you're trying to make sense of that again, how y equals square root of x squared is the same as the absolute value of x.